Authorities in Greece have declared a state of emergency after the most powerful earthquake so far shook the island of Santorini.
Authorities in Greece have declared a state of emergency after a powerful earthquake struck the island of Santorini, a popular tourist destination known for its volcanic history and stunning landscapes. The tremor, measuring approximately 6.8 on the Richter scale, occurred in the early hours of the morning, sending shock waves across the Aegean Sea and causing structural damage to buildings, roads, and key infrastructure on the island. According to the Hellenic National Seismological Institute, the earthquake originated from a fault line beneath the caldera of Santorini, an active volcanic system that last erupted in 1950. This has raised concerns among geologists who warn that increased seismic activity in the region could indicate deeper geological unrest. Over the past several months, researchers have detected a rise in underground magma movements and an unusual surge in gas emissions, suggesting that the volcano might be reawakening. Local authorities have begun evacuating residents from high-risk areas, particularly in the towns of Fira and Oia, where some buildings have suffered significant structural damage. Emergency response teams, along with the Greek military, have been deployed to assist in rescue operations, provide medical aid, and assess the stability of infrastructure. Scientists are closely monitoring the region using satellite imaging, seismic sensors, and thermal mapping to detect any further activity that could indicate an impending eruption. The Greek government has also issued travel advisories, warning tourists to avoid unnecessary visits to the island until further notice. The Santorini volcano is part of the Hellenic volcanic arc, one of the most seismically active regions in the Mediterranean. Experts fear that continued seismic disturbances could destabilize the island's geological structure, potentially triggering landslides, tsunamis, or even a significant volcanic event. Disappearance of magma and formation of a dike. Recent observations indicate that approximately 3 million cubic meters of magma have vanished from the subterranean chamber beneath Santorini. This disappearance is linked to the formation of a dike, a vertical fissure that allows magma to move laterally within the Earth's crust. Such developments are critical in understanding the dynamic processes occurring beneath the island. The formation of a dike suggests a significant shift in the underground magmatic system. Dikes form when magma intrudes into fractures in the surrounding rock, often in response to increased pressure within the magma chamber. The migration of magma along these newly created pathways can lead to surface deformation, seismic activity, and, in some cases, eventual eruptions if the magma reaches the surface. Geophysical measurements, including GPS data and satellite-based interferometry, indicate that the ground above Santorini has experienced slight uplift and deformation, suggesting subterranean movement. Additionally, seismometers have recorded increased microseismic activity, which could be attributed to the fracturing of rock as magma forces its way through the crust. The presence of these signals confirms that the magma is not merely disappearing, but is instead being redistributed within the volcanic system. The implications of this event are significant for both scientific research and hazard assessment. Santorini is an active volcanic system with a history of major eruptions, including the massive Minoan eruption around 1600 BCE. Monitoring changes in magma movement is crucial for predicting potential future eruption and ensuring timely warnings for local communities and tourists. Further analysis, including gas emission studies and thermal imaging is necessary to determine whether the magma is still migrating or has settled into a stable underground reservoir. Continued monitoring of the dike's growth and associated seismicity will be essential in assessing the long-term impact of this event on Santorini's volcanic activity. Scientific analysis of magma intrusion and seismic activity, a collaborative study conducted by leading institutions, including the Centre National de la Recherche Scientifique, CNRS, in France, the National Observatory of Athens, the University of Patras, and the National and Kapodistrian University of Athens, has provided valuable insights into the current crisis. Their research, detailed in a recent update titled Ground Deformation at Santorini, Preliminary Volume Estimates of Magma Involvement, assesses magma accumulation, seismic activity, and surface deformation. One major focus of the update is the Santorini seismovolcanic event. By analyzing GNSS time series data and preliminary modeling, scientists are interpreting ongoing activity and its potential implications. Rising concerns over the Columbo underwater volcano. A significant area of concern in the Santorini volcanic system is the Columbo underwater volcano, located just 7 kilometers off the island's coast. Research conducted over the past year has identified a shallow magma chamber beneath Columbo that has been steadily accumulating magma, reaching levels comparable to those observed before its last major eruption in 1650 CE. Given Columbo's history of highly explosive eruption, the recent increase in seismic activity around its main crater, as well as several smaller satellite craters, has raised significant concerns among scientists and monitoring agencies. Studies have shown that Columbo's eruptions tend to be violent, primarily due to its interaction with seawater. The explosive nature of its past activity makes continuous monitoring essential to detect early warning signs. Recent seismic swarms and changes in hydrothermal vent activity indicate that magma movement within the system is ongoing, leading researchers to believe that pressure is building beneath the seafloor. To improve monitoring capabilities, several new seismic stations were installed last year, with 4 additional stations recently added. These instruments provide crucial data on earthquake activity, ground deformation, and potential pre-eruptive signal. However, despite these advancements, a lack of data-sharing agreements between different research institutions and fragmented data ownership have hindered comprehensive analysis. The absence of a centralized monitoring authority has made it difficult to integrate seismic, geodetic, and hydrothermal data into a unified model of Columbo's current state. Moving forward, efforts are being made to improve collaboration between international and regional institutions, ensuring that data collected from different sources is effectively shared and analyzed. Scientists are also advocating for the deployment of underwater pressure sensors and ocean bottom seismometers, OBS, which could provide more detailed information about the dynamics beneath Columbo's crater. Additionally, researchers are considering gas monitoring stations to detect rising emissions, which are often a precursor to increased volcanic activity. Given Columbo's proximity to Santorini and its eruption potential, ongoing research is crucial for developing effective early warning system. If signs of an impending eruption become more pronounced, authorities may need to take precautionary measures, including issuing alerts for marine traffic and ensuring emergency preparedness for nearby coastal communities. The challenges posed by Columbo highlight the need for international cooperation in volcanic hazard monitoring, as early detection and coordinated response efforts could be crucial in mitigating risks associated with future eruption. Challenges in monitoring volcanic activity. One of the most significant challenges in assessing Santorini's volcanic activity is the inconsistency in available GNSS data. Reliable and continuous geodetic measurements are crucial for detecting ground deformation, which can indicate magma movement beneath the surface. However, discrepancies in the number of active monitoring stations, data ownership issues, and gaps in access to complete data sets have created uncertainties in the interpretation of volcanic activity. A historical comparison reveals that during the 2011 to 2012 volcanic unrest, there were approximately 10 GNSS stations actively tracking deformation across the Santorini caldera. These stations provided essential data that helped scientists understand magma accumulation patterns and assess eruption probability. However, following that period of heightened activity, many of these monitoring stations were removed, and currently only 3 operational stations remain. This dramatic reduction in coverage has limited the resolution and accuracy of real-time monitoring efforts. Compounding this issue, some GNSS stations appear on monitoring maps despite unclear status and ownership, making it difficult for researchers to determine whether they are still providing reliable data. This lack of transparency complicates scientific assessments, as incomplete or outdated information can lead to misinterpretations of volcanic hazards. The inability to access full data sets in a centralized and coordinated manner further hinders the development of accurate deformation models and predictions. To address these challenges, scientists and institutions have been advocating for the reinstatement of more GNSS stations across the Santorini region, including the caldera, the Camini Islands, and surrounding volcanic features like Columbo. Expanding the network would improve the detection of localized ground movement and help differentiate between minor subsurface adjustments and more significant precursors to volcanic activity. Additionally, there have been calls for greater international collaboration to ensure that monitoring efforts are standardized and that data-sharing agreements between research institutions are established. Implementing automated data integration system could also help provide real-time updates, allowing for quicker responses to any signs of renewed volcanic unrest. Given the history of explosive eruptions in Santorini, including the Minoan eruption 1600 BCE, and more recent activity in the 20th century, ensuring comprehensive and continuous monitoring is essential for both scientific research and public safety. Moving forward, securing funding for new instrumentation, improving coordination among agencies, and enhancing real-time data access will be critical steps in mitigating volcanic risks in the region. Ground deformation and magma movement. Despite these challenges, scientists have identified significant movements at key monitoring stations. Notably, the SN station, positioned closest to the inflation zone, has recorded substantial upward displacement. Alongside the Chios and Uranus station, data reveal that land deformation began accelerating in mid-2024. Since January, a pronounced shift has been observed, with elevation at the SN station increasing from 60 millimeters to over 100 millimeters. Updated GNSS time series data from February 11th highlight 3 critical movements: upward displacement, northward drift, pronounced northeastward shift. Interestingly, this pattern aligns with the trajectory of the recent seismic swarm, which has consistently migrated northeast since its onset. A deflationary trend was detected around January 20th, followed by an abrupt acceleration in movement on January 29th, a shift that remains ongoing. Possible links between seismic swarms and magma intrusion. A second seismic swarm, which ended on January 25th, was quickly followed by a new sequence beginning January 26th. However, seismic stations only detected these movements by January 29th, marking that as the official start date. The increasing velocity of land deformation suggests an intensifying force beneath the surface. However, the concurrent deflation raises questions about the driving mechanisms behind these changes. A similar pattern has been observed in Iceland, where repeated cycles of magma migration and surface deformation have occurred almost monthly since 2007 November 2023. One particularly relevant case from November 2023 involved a massive magma intrusion forming a 15-kilometer-long dike, triggering intense seismic activity, potential for eruption or further deformation. The continued seismic turbulence at Santorini raises pressing concerns. Is this event a prolonged magma intrusion, or is another factor at play? Given the numerous fault lines in the region, tectonic stress may also be amplifying seismic activity. If magma interacts with a fault, it can create additional pathways, allowing further movement and sustaining the swarm. This could, in turn, trigger secondary fault ruptures, setting off a chain reaction of seismic and volcanic activity. Satellite data and GNSS analysis indicate magmatic accumulation. Recent satellite imagery and GNSS data indicate concentrated uplift in specific areas, reinforcing concerns about magma accumulation beneath Santorini. Time series graphs from January 2025 show an initial upward trend, deflation around January 29th, coinciding with the earthquake swarm. Brief stabilization, followed by another significant drop. A key question remains: did magma escape the chamber, or is it redistributing within the system? A subsequent increase in elevation suggests that deeper sources may be replenishing the reservoir, creating cycles of inflation and deflation. Estimating magma volume and its implications. Recent geophysical and geodetic analyses indicate that approximately 6.5 million cubic meters of magma have accumulated beneath Santorini at a depth of 4.3 kilometers. While this volume is relatively modest compared to the vast magma reservoirs involved in Icelandic eruptions, the composition of Santorini's magma presents a heightened risk of explosive volcanic activity. Unlike Iceland's basaltic magma, which tends to produce more fluid and effusive eruption, Santorini's magma is more viscous and silica-rich, increasing the likelihood of gas buildup and pressure-driven explosive eruptions. Ground deformation data suggests that the maximum vertical uplift in the region has reached approximately 90 millimeters, with a steady inflation rate of about 33 millimeters per month. These measurements indicate that magma is actively accumulating within the volcanic system, causing pressure to build beneath the surface. Scientists use GNSS stations and INSAR, interferometric synthetic aperture radar, imaging to track these deformation patterns, as they provide essential clues about the size, depth, and movement of the magma intrusion. While current uplift rates are not unprecedented, they are comparable to deformation observed during previous periods of volcanic unrest, such as the 2011 to 2012 inflation event, which ultimately stabilized without leading to an eruption. However, continued inflation at this rate could signal that the magma chamber is approaching a critical pressure threshold, potentially triggering Dyke formation, increased seismicity, and even a small-scale eruption in the near future. One of the primary concerns is the potential interaction between the accumulating magma and existing hydrothermal systems within Santorini's caldera. When magma heats groundwater or interacts with existing hydrothermal fluids, it can generate phreatomagmatic explosions, which are particularly hazardous due to their unpredictable nature and violent intensity. This interaction could result in ashfall, steam-driven blasts, and localized tsunamis if a submarine eruption were to occur. To refine these estimates and assess potential eruption scenarios, researchers are conducting further seismic tomography studies, gas emission analyses, and thermal surveys. If inflation trends continue at the current rate, additional monitoring stations may be needed to track deformation in real time and provide an early warning system for significant magmatic movements. While there is no immediate cause for alarm, the accumulation of magma at shallow depths requires continuous monitoring and updated risk assessments. Authorities and scientists are working closely to ensure that data collection, public awareness, and hazard preparedness are enhanced in the event of a sudden escalation in volcanic activity. Is this a warning for a new eruption? Recent data suggests that approximately 3 million cubic meters of magma have left the chamber, reinforcing the likelihood of an active intrusion beneath the surface. The key question now is whether the chamber is undergoing cycles of refilling and depletion, a pattern seen in various volcanic systems. If the magma has moved into a lateral dike, it may be lodged within the upper crust, seeking the easiest path toward the surface. GNSS data suggest a dike with an estimated width of 1 kilometer and a length of 30 kilometers, though its current thickness appears to be only 10 centimeters, an unusually small measurement that warrants further investigation, ongoing monitoring, and future risks. To gain further insights, An additional GNSS receiver was installed on Nisi Island on February 12th. Positioned east of Santorini, it is a crucial observation. While preliminary data has been collected, more readings over the coming days will help refine assessment. However, a significant gap remains: the Columbo underwater volcano. Its proximity to the ongoing earthquake swarm makes it a critical area for monitoring, yet real-time data from this region is scarce. Without updates from Columbo, scientists are missing a key piece of the puzzle in understanding the full scope of this seismic and volcanic unrest. While predicting the next phase of volcanic activity remains challenging, these findings provide a deeper insight into the complex processes occurring beneath Santorini. Scientists have long been aware that the island's caldera is an active system, but recent seismic and geodetic data suggest that magmatic movements beneath the surface are evolving. What does this mean for Santorini? The shifting magma chamber beneath the island indicates that pressure is building, but whether this leads to an eruption remains uncertain. Similar patterns have been observed in the past, with inflation episodes that did not result in an eruption, but instead represented a natural readjustment of the system. However, past events, such as the eruptions of 1925 to 1928 and 1950 were preceded by similar signals, raising concerns among volcanologists. Could this be an early warning of a new eruption, or is the island's restless system merely adjusting to internal changes? The answers lie in continued monitoring efforts. Scientists are relying on satellite-based measurements, ground deformation sensors, gas emissions analysis, and seismic activity tracking to understand what's happening beneath the surface. Any significant acceleration in these signals could indicate an increased eruption risk. Santorini is a prime example of an active caldera that requires close observation. Volcanologists are urging local authorities and residents to stay informed, while also reassuring them that no immediate danger is present. Future research will be crucial in deciphering whether this is a short-term fluctuation or a sign of impending activity. What do you think? Could we see another eruption in our lifetime? Or is this just another episode of minor unrest? Let us know your thoughts in the comments. Stay updated on volcanic activity, scientific discoveries, and more. Subscribe now and turn on notifications so you never miss an update. Alarma,